Folks, before we get started, it's a packed audience, which is fantastic. If there's any seats available, or if you want to scoot over a bit and let more people in, that would be wonderful. So let's get started. Welcome, everyone. Great to have you here at Build 2012. My name is Andrew Byrne, and I'm a programming writer with Windows Phone, and this is my colleague Doug Rothus from Windows. Now, we're here today to show you some sharing techniques you can use to share code between your Windows Phone 8 app and your Windows 8 app. And using these techniques will save you time and money. The techniques we're about to show you we'll do using an app that we built to show these sharing techniques. So here's our agenda. First of all, we reiterate the fantastic opportunity that you've heard about already today, but is right in front of you. We look at the Windows Phone API and the developer choices there in terms of building apps. And then we look at some sharing strategies for sharing code when you're building an app for Windows Phone 8 and Windows 8. And we'll do all of this through a set of demos and code. So it's a fantastic time to be a developer on the Windows ecosystem. It was mentioned already today by Steve Ballmer and various others. You have the potential to put your apps into the hands of millions of new customers right across the world in over 191 markets. And it'll be apps that were core to the Windows Phone and Windows 8 experiences. The start screen on both devices will put your app at the center of that experience. Now, your apps and your scenarios, they're going to light up all the new hardware and devices that you're seeing. You saw some beautiful hardware and devices this morning. It'll be your apps that'll make those rock. And you'll want to build these great apps for both platforms as efficiently as possible. And you'll be able to do just that using the techniques that we're going to show you today. We are on the path to Windows and Windows Phone convergence. Here's what I mean by that. The Windows Phone 8 release is a huge developer upgrade. We've added a shared core with Windows, and on top of that, we have a native app development stack. And we've also added a ton of Windows Runtime API, a lot of which is shared with Windows. So you can see some convergence happening there. This platform and the convergence will allow you the flexibility and power to build really compelling apps. Let's have a look at the Windows Phone API. So in the Windows Phone 7 days, we had our Silverlight apps that we built on .NET writing in C# and VB. We still have that in Windows Phone 8. And in fact, we've done a lot in terms of improvements there too, and we've added new APIs such as for Wallet. But along with that comes the Windows Phone Runtime. Now what that is a set of Windows Runtime API, a lot of which is shared with Windows 8, and we've added some more for features that are specific to the phone, such as speech and voice over IP. And because it's Windows Runtime API, you'll be able to code against these using C#, VB, and C++. And last, but definitely not least, is our native app and game developer stack. Here we support Direct3D, Xaudio 2, and so on, allowing you to build fantastic native apps and games on Windows Phone 8. Diving a little deeper, I want to show you what this looks like in terms of laying out the API against features and the languages you can use to code against them. So on the far left, we have the .NET API, and there you can use C# and VB. And in the center, we have Windows Runtime API. And again, you can code against these in C#, VB, C++. There's a lot of overlap here in terms of a common Windows Runtime API that we've adopted from Windows 8. And then we have our developer stack, and you can code there in C++. And all of this lying, once again, on top of a shared core. So this platform in terms of Windows Phone 8 will give you the power and the flexibility to build your apps your way. So to frame the rest of the talk, we'd like to do a little demo. This is an app Doug and I wrote to show you some of these sharing techniques. So Doug, over to you.
All right. Am I on? No. Hey, Mark. All right, there we go. All right, let's switch over here. Let's we made our sacrifices to the demo gods, so hopefully this will all go without a hitch. We're working with multiple devices here. So here's my Windows 8 tablet, and what Andrew and I built for our sample app was a picture sharing app. It allows us to share pictures between devices. We connect them using proximity, using NFC, and then we can send pictures back and forth without actually having to copy them from device to device. So here's our little demo. So as you can tell, I can tell people in the back, everyone can tell that I am very invested in my hair. Yeah. And I like to try a lot of different hairstyles. And so I'm going to share these. I've got some mock-ups that I want to share with Andrew, get his opinion on. So, hey, Andrew, how's it going?
Hey, Doug, long time no see.
Yeah. Now, you know how invested I am in my hair.
Oh, yeah.
Oh, yeah. So I want to share some pictures with you. So I'm going to start up Pix Presenter here. And you'll see it's basically just bringing up the photo albums from my local device, and I get all the Windows 8 goodness. And so I'm going to connect with Andrew. So I bring up the app bar, and I select my connect button. And at this point, I'm going to switch over. So now we're going to tap.
Hard to see.
It's hard to see. And it prompts Andrew to open up the Pix Presenter on his end.
Connected.
And now what he's got is the same application, but optimized for Windows Phone.
And showing my photos.
Right. So I open up my picture album here, and all I do is I'm just going to flick over the first photo to Andrew. Now, Andrew, I call this my Anchorman
Very
look.
Nice, Doug. I'm liking it.
You liking
I
that?
can see that happening, but
Okay.
Give me something else.
Okay, well, I was thinking of going a little more hip. This is my Justin Bieber look.
Nice, very modern.
Yeah, I was worried
Love
about
it.
that one requiring more product, so
Yes.
it might be more expensive hair.
You don't want to have too much expense.
Yeah, but I was thinking of going way out. I call this one Ziggy Stardug.
Try it again.
So here it comes. I did it. It's coming twice.
Hey, Ziggy. I'm loving it.
Yeah.
Doug, that would look beautiful in black and white.
I'm liking the
very
tattoo.
retro. I love the tattoo. I hope it's permanent.
Oh, so you want a black and white picture?
Yes,
okay.
please.
Well, that'll be a little more artsy. So I'll just change it to black and white and flick that one over to you. And it's going over Bluetooth, and there it is.
Beautiful. Well, Doug, that was fantastic, and I wish you all the best in your hair search. And just to go in the opposite direction, I'll send over what I'm going home to tonight.
All right?
So there you go.
So switching back, we'll see that that now shows on my tablet. And you can all be thankful that we didn't show the hair pictures in that big of resolution. So that's Pix Presenter.
And that's Redmond weather for you. Thanks very much, Doug.
Certainly.
So that's the app we're going to use to show you some of these sharing techniques. And I just want to outline up front what those techniques will be, and we'll go into more depth on each as we go through all the demos. The first thing to do to set yourself up for success in terms of sharing, and it will probably become quite natural to everybody writing these kind of apps, will be to separate the UI from app logic. Use any separation pattern you like. MVVM is obviously one that's very suitable, and we'll dig into more details as we go along. Then there's an opportunity to share a lot of .NET code, portable .NET code in a portable class library. This will be written once and shared across both apps. We'll then walk through some use of the common Windows Runtime API, and we'll show single source there in terms of sharing code using the add as link technique from Visual Studio. And then we'll wrap up and show the use of a Windows Runtime component that you can build and you can use for language interop and various other things in your app. So let's talk about separate UI from app logic. Here's an elementary diagram showing basically an app that consists of user interface and app logic. And the goal, as we talk here, is to get that user interface and separate it from the app logic. Now, for those of you familiar with model view, view model, in that particular design pattern, what we have here is at the very bottom layer, we have the model or the data that represents your app and some functionality there. That data we want to consume in our application. We do that through one or more view models. So they encapsulate for us what we want to show in terms of data to the user in our app. And on top of that, we have one or more views. And in a Windows Store app and a Windows Phone app, a view equates to basically a page of UI. So already, what you can see there is if we use the MVVM design pattern in our app, what we end up with is nice, clean separation between view and the rest of the code. Let's look at the Pix Presenter project. As you can see, we have our Windows Phone app and our Windows Store app. We use MVVM here. And as you can see, hopefully by looking at this diagram, the first thing that should spring to mind is that we're already sharing. What we've done is we've shared the app structure and app design. So this is great. This is one of the advantages of writing both apps at the same time. So at the bottom, we have our model, which in this case was local pictures, such as the ones Doug was showing. We have app logic. And inside the app logic, there's a set of view models which are used to basically access the local picture libraries and to present those pictures to the UI. It does a lot more than that. You saw us using Tap and Connect proximity API. You saw us sending pictures back and forth. So all that's taken care of roughly in that layer, in the app logic layer. And then the app itself is made up of 3 views, or 3 pages of UI. You have the very first page, which shows the list of albums, then an album itself full of a list of pictures, and then when a picture comes across, it's shown in a separate view called a picture view. So that was just an overview in terms of separation of UI from app logic. One reason we want to do that is we want to start sharing a lot of code in terms of app logic. But another reason is that it sets you up for success in terms of designing your best user experiences in terms of the UI. So you've got those separated, you can concentrate on each one. Let's look at portable class libraries. Now, they've been around for a while, but a portable class library is a key ingredient here in terms of code sharing in a XAML app. The reason being is that the app is written typically in C# and VB and uses a lot of the .NET framework. So what does a portable class library do? Well, in Visual Studio, when you create a portable class library, this wizard pops up, and it's asking you to pick the platforms you wish to target with this library. In our case, we'd choose Windows Store app, Windows 8 app, Windows Phone 8 app, excuse me. Once you do that and you hit OK, it would create a project, and in that project, you'd have a set of .NET assemblies that are guaranteed to be portable for the platforms you are targeting. And then in there, you'll write some of your code that you want to be portable to. What it ends up giving you is, one, you write in your source once, you write it in one of these projects. In our case, we had one portable class library. But you're compiling to a binary which is portable across Windows 8 and Windows Phone 8. And what that means is you can target multiple platforms. And we're going to show you how to do that as well. So that's a simplified look at portable class libraries. I want to relate it now back to something like MVVM, where you have views, view models, and models. So in this diagram, this is actually the structure of our solution. We have a Windows Store app, which is a project in our solution, and I'll show that shortly. We also have a Windows Phone app. And in these, we're going to basically create a lot of our UI, our experiences in terms of what the user sees. And that's the recommendation, is to do that inside your platform-specific projects, your app-specific projects. They'll both reference one portable class library, And what we do in there, and what you can do is share, place your view models and models. So a lot of your app logic will go in there. It won't be a clean separation always. There'll be cases when you'll have something that's platform specific. And when you do, you'll have to think about ways to call that code from within the portable class library. And the recommendation there is that you have an abstraction inside the portable class library that will define basically that functionality. You'll implement concrete implementations of that in both your Windows Store app and your Windows Phone app. And then, for example, when you're constructing your view model, you'd pass in that concrete implementation, and that would be called by the view model. And I'll show you an example of that now. Just back to what's portable in PixPresenter, remember, same structure, same design, model view, view model. What in this application is portable? We've said it already, and you'll probably hear us repeating it because it's worth repeating. We designed the user interface and the custom and the experiences to best suit each platform. And you'll probably want to do the same. So from a what is portable perspective, the view layer, the UI will be platform specific. You'll get the most return on your investment in terms of portability or sharing in at the app logic or view models layer. We'll describe what we mean by shareable as opposed to portable shortly. And in the case of PixPresenter, the API used to access the photo libraries on both platforms is platform specific. So let's get on to some demos. Excuse me. So in demo 1, I just want to show you the portable class library and our use of MVVM. Here's our solution inside Visual Studio. And as you can see, it's made up of 3 projects. Now that's done for convenience in terms of one solution with the 3 projects. But just remember that when this is compiled, it'll generate the portable class library, the app for the store, and the app for Windows Phone. When we expand the portable project, you see here we have some view models. So let's take a look at the album view model. All this is a representation of an album inside the application. And as expected, it contains a list of pictures, public property, which is a list of pictures, a name of the album, a path, and then some way to load up some pictures. We also do some level of flow interaction here. So as Doug was flicking through the pictures, he's basically asking this to give him the next picture, and it's responsible for setting that current picture, which is then displayed. So that's the album view model. It's quite straightforward. The albums view model sits on top of that, if you like, because what it contains is the list of albums. So it's very simple. It just has a property, exposes a collection of albums, and it has a method that's called during initialization to load the albums. So in this very first demo, I've done something very straightforward. All I'm doing is populating this view model with fake data, sample data. I just wanted to show you this running, keep it straightforward. So let me show you the view models then being initialized inside one of the projects. Here I am in the Windows 8 project. I have my views defined in here. I'll scroll down, what I should have done. And you can see when I navigate to this page, I'm calling load albums async, and I'm setting the data context of that page. And that just allows then the UI to bind to the properties of this view model, such as showing a list of the albums and showing the name of each album and a thumbnail. And that's the same for both projects. If I look in the Windows Phone 8, I didn't show you that in the Windows 8 project, but I've got a reference to the single portable library, portable class library. And in the views, I'm doing the exact same thing. I'm basically loading up the albums and setting the data context, and then in XAML, I'll bind to that view model. So I have my Win8 app as my starter project currently, and I'll just show you that running. If I open up the simulator, hit run, Pixel comes up, and then you see some of that sample data. Very straightforward. Now I'll go back to the Solution Explorer. I'll right-click and set Windows Phone 8 as my starter project. And this time I'll run it in the emulator for the phone. And there you go, the same data showing up in the albums. I won't click through because there's nothing else in terms of sample data behind this. I was just showing the album structure. So that's it, pretty straightforward for the first demo. Want to drive home the point that this is code written once, it's compiled and shared between both our Windows 8 and Windows Phone 8 projects. Go back to that. So that's never going to make prime time. I'm loading up sample data. We don't want to just stop there. We want to do the real thing. And as I mentioned already, and I'm kind of, cut into the chase, like Luke Skywalker, Darth Vader was Luke Skywalker's father, that kind of thing. But anyway, I've cut into the chase there. I know. That's what I was trying to get to. Thank you. A spoiler. And the spoiler here is that in this particular app, in the PixPresenter project, accessing the photo libraries was platform specific. On the Windows Phone app, we used the Media Library API. And on the Windows Store app, we were using the Windows Runtime Storage API. And I'll show you all that in a second. So what to do? Well, we have a portable class library. We were filling it with sample data. How do we now, in that view model that we showed, start to consume platform-specific functionality? And going back to the diagram that I showed earlier, here's what we're going to do. Inside the portable class library, we're going to define an abstraction for this functionality. And what that abstraction is, in our case, would be just a simple interface to retrieve data for us. Once we have that interface defined, the view model can then use that interface in terms of calling in to get the data. But we'll implement it concretely in the phone app and the store app. So they'll code up those functions necessary to get the data. And then when at runtime, when we're constructing the view models, we'll have already instantiated whatever class or object we need that has that concrete implementation. And we'll inject that into the portable class library, form a dependency injection for those who are familiar with it. And I want to show you that now. This is dry work. Okay. So here we are back in Visual Studio. And as a reminder, we had that dummy data, and we want to actually now do something concrete. So over in our Solution Explorer, you'll see there's now interfaces defined. Let's take a look at the iAlbum service interface. Very simple. It's using the wonderful asynchronous API that's now available. So it's basically a method that when called will asynchronously retrieve album data in the form of album view models. So we can grab those and stick them into our list, present them to the UI. So that's inside the portable library. That's where we're defining this platform-specific abstraction in the portable class library. How is that consumed? Well, inside the albums view model, I've now gotten rid of that dummy data. We don't want that. And what I'm going to do now is just show the injection of that interface in here and writing a little bit of code. So here I'm defining local variable. and that's going to be used to store my album service interface. Here's where the injection happens. So I'm passing in an iAlbum service, which will be implemented on each app. I'll store that. And then down where we had load albums async, what I'll do there is use the new interface. So it returns me a list of albums. So here I'm calling get albums async, and I'm going to just use the results straight up to grab that list of albums. And now I want to populate my collection, my property of albums. And I'll do that by passing in the album list. So that's it. Simple use of that interface. This new model knows nothing of the implementation, doesn't know who implemented it, just cares about the interface. So it's a very powerful technique that I'm sure a lot of you out there are familiar with. Okay, moving forward, that's all happened inside the portable library. And now inside each of the apps, they're going to just implement the concrete implementation. And we don't have time to go through all of this, but I just wanted to show you, here's the Windows 8 app. And as you can see here, it's implementing iAlbum service and the method getAlbumsAsync. And here you see it using some of the Windows Runtime Storage API. It's going to iterate over all the albums on the local device or PC and pass those back as a collection. Same thing for the phone. Implements the interface. And here you can see it's using a different API. It's using the Media Library API, which was available also in Windows Phone 7. It's iterating over all the albums using that media library, and it'll create the same list of albums. So let's see that running. I have my Windows 8 app as my starter project still. Oh, didn't mean to do local machine. It's all the same. So now you can see it's getting real data from the device, which happens to be this PC. And I can drive through it and see a lot of the different pictures, which is great. I'll go back to the Windows Phone 8 app. I better stop debugging. And here I'm going to set the starter project again. I have the VGA emulator open, so I want to run it on that just to save myself a few seconds. And there you see it's pulling up the albums that are on the emulator, which is just this sample pictures album. So that's it for portable class libraries. We've shown you the power in terms of sharing portable .NET code, and then how to get around having platform-specific dependencies, doing a form of dependency injection by using an interface. And in these type of apps, SAML apps, you'll get a long way with this particular technique. So now Doug's going to show the use of the common Windows Runtime API. Doug, over to you.
All right. Thanks. I don't know if I'm on.
I'm sorry? Great question. Can we keep the questions till after? We've lots to get through, but I'll try and answer that at the very end. Let's make that our first question to answer. Thank you.
All right. So common Windows Runtime API. So with Windows 8, you have the new Windows Store app application type. And to help you develop store apps, you have now the Windows Runtime API. And that gives you access to all the goodness that is Windows 8. Sensors and proximity, as we showed earlier, the media, and all kinds of stuff. And as Andrew mentioned earlier, Windows Phone 8 is also introducing the Windows Phone Runtime API, which consists of some API that's specific to phone, such as, like we mentioned, speech and voice over IP. But it also has adopted a subset of the Windows Runtime API, and that code is the exact same code as on Windows 8. So it's common code. And so that presents an excellent opportunity for you to write once and have code that works on both. Now, Andrew also mentioned that there's a difference in what we're calling portable code, which can go, as he just showed you, into a portable class library, and what we're calling shareable code. Runtime code cannot be put into a portable class library. So you can still use the add as link feature to share that code from a single source to multiple projects, and that's what I'm about to show you. So let's look at this in the terms of, under the lens of PixPresenter. So with PixPresenter, you saw that we had the proximity capability where you could tap the devices together, and then the result of that tap was an open socket connection between the two, and we used Bluetooth as the transport. So we factored all of that proximity and networking code into a single class called Peer Connector. So let's look at Peer Connector. Now here I'm actually showing you Visual Studio, and you see the multiple projects, but I'm going to go into the file system, because what we've done is we just, for our own file organization simplicity, if you will, we stored all of our shared files outside of the project. So I have the shared folder, and then there's code, and in here you'll see I have my Peer Connector class. And what this allows me to do is then, this is just the way we chose to implement it, but we can keep a single source that is then shared into the projects rather than having it in one project shared to another. Not a requirement, but it helped us organize things. So let's have a look at the Peer Connector class. I'll open it up in Visual Studio. And this, once again, is just to give you a flavor of what's in there. You'll see that right off the bat, we're importing types from the runtime. And once again, that's common code, common namespaces, same code on both platforms. We have a couple public events that we expose. So we have the picture received event, and that tells us when a peer app has sent us a picture. We have the connection status changed event, and that tells us when we've successfully made a connection or the connection's been dropped, and that allows the UI then to be responsive to the user and tell them, you need to tap or you've lost the connection, etc. You can see down here in our public constructor, we're checking first to see if you can do tapped connections, which is called triggered in the API. And then if that's available, then we'll initialize the peer finder object. That's, once again, same object on both platforms. Just a little bit more in here as we go down. We have public methods to start and stop a connection, and we have a public method to send a picture. Picture being received, that's all coming through the event model. All right. So let me close that one down. So now I have my project. My Windows 8 project here is where I'll start, and I want to include that file in my project. So I'm just going to go down to my View Models folder. I'm going to add, and I'm going to add an existing item. I'm sure you've all done this hundreds of times. And then I'll navigate back to that shared folder where we stored things, shared and code, and there's Peer Connector. Now, I'm sure you've all done this 100 times as well, if not more, is that you grab an existing item and you just add it to a project. But what that does is that actually adds a copy of that item to your project, and what we want to do is we want to single source the code so that if I make a change to the code, it propagates to both my Windows 8 and my Windows Phone 8 project. So I'm going to go down to the Add button, I'm going to extend the drop down, and I'm going to select Add as Link. So now what Visual Studio has done is it's linked that file into my project. It still builds as part of my project, but the source exists somewhere else. You can actually see, if you have eagle eyes, that Peer Connector actually has a slightly different icon than a file stored in that project to show that it is linked. So let's see that running. We'll just set a breakpoint and we'll break into it. I'll start up a simulator. And here it comes. Faster than a speeding bullet. Maybe I probably didn't click it. I think I selected it without clicking it. There we go. All right, so now at this point, let's enable some touch. Bring up the app bar, click the connect button, and there we are. We've broken into that link code. So let's do the exact same thing, but we'll do it for Windows 8. Windows Phone 8. I'll select my Windows Phone 8 project, set it as a startup project, go down, same folder, add an existing item, and go to that same shared code folder, grab Peer Connector, and add it as a link. And it's the exact same file. You'll see, actually, I never closed the file, but it actually persists the breakpoint that I set. And now let's run the Windows Phone 8 one. Click it this time. Here comes the emulator. And there's PixPresenter. Open up the app bar, select Connect, and now we're broken into that same code. So we've been able to write code once from the runtime and share it to both Windows Phone 8 and Windows 8. So just to finish this up, let me go back. And you are probably wondering, what can I share? So this is our Venn diagram, which shows you the convergent section of the two runtimes. In the blue, the light blue, pardon me, that's where you have those Windows Phone specific runtime. In the red, you have stuff that's specific to Windows 8 or stuff that hasn't been implemented yet. And then what you have in the blue section in the middle is all these services that are available to you in the runtime on both platforms. And once again, it's the same code, the same API. And that's networking proximity like you saw in PixPresenter. You also have in-app purchase, sensors, location, file system. The core application model is the same, and threading is the same. So that's the end of my demo. Let me turn it back over to Andrew for Windows Runtime Components.
So thanks very much, Doug. So now you've seen a couple of techniques for sharing portable class libraries, binary sharing, and then using this common runtime API and the investment in there. You can use that now in your apps to share code right at once and share everywhere. What about Windows runtime components and how are they different to the API Doug just showed? Well, the Windows runtime API are natively built into both platforms. What we mean by Windows runtime components, sometimes called third-party Windows runtime components, are the ones you create yourselves. So you have templates inside Visual Studio that will allow you to build your own Windows runtime components. And when you do that, you're going to expose your functionality and it'll have a WinMD file, which is the metadata that means it can be projected into all supported languages. So you'll be able to code against whatever's inside the Windows runtime component using the usual C#, VB, C++. And it's a very powerful technique. And I'm going to show you that. So at this morning's keynote, Kevin showed PixPresenter and he showed this functionality. So I'm not going to go into as the same detail as him, but I'll show it from a slightly different angle. Here was the goal in our app. We're all victims of scope creep, and we had time in our hands and wanted to show off more in terms of what we could do in our application. So we thought it'd be a great idea to add some kind of filtering so that when we're sharing these pictures, we can convert or filter to some nice special effect and then send the pictures, flick them across to the other device. That's the genesis of really this filtering library that we built into PixPresenter. So rather than go and build that ourselves, and it happens quite frequently in the real world, there's code that we already have in our organization. Maybe there's a third-party library that does a great job. And in this case, what happened was that our colleague had a small little library that he had written, I believe it was 10 years ago in college, so it's a pretty straightforward piece of C++ code. We decided we wanted to use that in PixPresenter. It's C++ code. We've got a XAML app written in C#. How are they going to work together? And this is where one way Windows runtime components come into play. So let's take a look at that. you'll notice our set of projects has expanded slightly. We have 2 projects called Fast Filters, one for Windows 8 and one for Windows Phone 8. Now what these are basically the containers for this small little library. As you can see, for those of you who in the C++ world, this is C++. And what all it's doing is taking in a buffer of pixels, converting it to grayscale and passing it back. Very straightforward, and it's really just for demonstration purposes here today. So with that code, we created a Windows Runtime component project inside Visual Studio, and we placed that code in there. And we did that for both Windows Phone and Windows 8. And just like Doug was showing, this code is single source, so these files are actually linked. By default, they're linked in native projects. But it's the exact same code, so if I was to double-click here, we're not going to open up a new file because it's the exact same. So the Windows Runtime components, they're not binary compatible. You want to compile them for each platform, hence 2 projects. So we have a project for Windows Phone, project for Windows 8, and we're compiling this code into each. Looking inside now how that's consumed, let's look at the Windows Phone 8 app. First of all, we'll see the reference to its Fast Filters library. And we consume that in a class called Picture Service. And this is 3 phases, basically. We pass in a byte array, which represents the image we want to convert. We're decoding that into raw pixels here. And then we're instantiating this filter, and we're calling convert image. When we get the converted buffer back, we're copying that back out to the image, and then that's displayed to the user. Very same thing inside the Windows 8 project. We have the picture service here, and here we see we've imported that library, that namespace for the library. And we're doing the same thing. We're taking in the byte array, we're decoding it, passing it to the filter, it's converting the raw pixels into grayscale, we're re-encoding, and then we're going to show it to the user. And just to remind you what that looks like, I'll set that as a startup project, although I think it already was. I'll run it in the simulator. Let's see if I'll just go into the Win8 project. How about a breakpoint demo? Was I too late? Should have loaded up. Start it again. No, it's not. Okay, it probably won't break. So anyway, I'll go into one of my pictures, flick around, find a picture I'd like to convert, flick up the app bar, tap convert, and it breaks into the C++ code from our XAML app. I didn't think it was going to. So that's great. I'll hit continue. Thank you, demo gods. I'll hit continue. I had 2 breakpoints, and ta-da, black and white. So that's a simple example of creating your own Windows Runtime component, wrapping code you have, existing code or third-party library code, and consuming that in all supported languages. Go back here. So in terms of a XAML app or an app like the one we have in PixPresenter, reuse of native code in this sense is really excellent for language interoperability. You just saw that. If you had some part of your app that was computationally intensive, maybe now is the time to write it in C++, wrap it in a Windows Runtime component, and expose that back to your XAML app. It's also great for consuming third-party libraries, a lot of which may not be written in the same language that you've written your app in. So that's it. They're the sharing techniques we wanted to show you today. And I just wanted to then pass on some of the lessons learned, and hopefully you can use these when you're building your apps too. When building your apps, architect with sharing in mind. We were lucky in the sense that we had a green field. We were building both apps at the same time. And if you have that chance, that's a great way to approach a project like this. The reason is that it sets you up for code sharing, because you can design from the get-go with sharing in mind. This will save you lots of time now and later. That's the whole purpose of this talk, is to give them, make sure you see that there's a potential for cost savings here by sharing code and sharing maintenance, saving maintenance costs over time. But sharing should definitely not mean that you're compromising the user experience. You want to build your best Windows Phone 8 app and your best Windows Store app in terms of user experiences. So an engaging experience on both of those platforms, it trumps sharing all the time. So the good news here is in PixPresenter, what we found is we didn't have to compromise. We were able to build our apps and our UI that suited both platforms and to share as well without any real compromises. It was a natural technique. I think some of that has to do with approaching the app with sharing in mind and setting ourselves up using the right design patterns and so on. And finally, using your existing skills and knowledge. There's a lot of cross-pollination when Doug and I wrote this application in terms of moving each app along. Sometimes I'd do a little bit of coding over on the Store app, and Doug would come over and do something on the Windows Phone app. I didn't have really any knowledge of building Store apps, and Doug was probably the same for phone apps. What we did find was our skills and knowledge in terms of from the tooling to the languages to the metaphors that are being used inside each of these app models are very similar. And then the app design itself and doing the project together really helped in terms of being able to talk the same language. Summarizing the sharing strategies, we started off separating UI from app logic. Will come pretty naturally to everybody here, and if they're using a separation pattern, if they're using MVVM, you'll already have the concept of views in mind, so that will set you off on the right path. The separation is great in terms of then figuring out what you can share or make portable, but it's also great in terms of having your projects, your Windows Phone and your Windows Store projects, really focused on experience and UI. We then talked about sharing portable .NET code in a portable class library. This technique is going to be very valuable to you, and it'll depend a lot in terms of the size of your app and the complexity of your app logic and view model, how much you can share, but we think you'll be able to share quite a lot there. And then from a convergence standpoint, Doug pointed out the Windows Runtime Common API, and we have a surface area there that is shared, and you can write your code once. You can use that as link and share that code, so you're writing it once and sharing everywhere. And finally, in an app like this, we showed you language interop using Windows Runtime Components. We're getting towards the end here. I just wanted to call out some of the resources here that we really recommend. There's obviously more to this story than just this one talk, and we really encourage you to visit some of these other talks. At the very top, you'll see Windows Phone 8 and Windows 8 app development. That's the documentation set that we wrote to go along with this, and it's available today with the release of the SDK at that link and up on MSDN itself. That points off to MSDN. From a talk perspective, Peter Torr, my colleague, is going to talk in depth about C++ app development on Windows Phone, and he'll go into some details there in terms of what you can do there in terms of building native apps and games, the project types available, etc., when to use Windows Runtime Components, and so forth. Really encourage you to go visit that talk. And Sam George has a related talk on game development. We've talked a little bit about best practice or getting the best experience, but best practices are also very important to make sure your app isn't the one that isn't on the start tile of each of the customer's devices. Stefan Wick does a great talk setting that up and explaining to you what makes an app not so good and what makes an app great. Daniel Plaisted from this Core CLR team is going to go into depth on the portable class libraries. I hope we touched on it enough here today. He'll go a bit deeper. He'll talk about more sharing across all platforms and using services and so forth. And Jeffrey Furman will talk about Blend and Visual Studio and using those for building apps on Windows 8 and Windows Phone 8. And you can see our doc sets at the bottom, and then Code Gallery will contain all the code samples, and we'll put PixPresenter and its supporting docs up onto Code Gallery shortly after build. So that's it. In summary, I think you're all sitting here because you realize there's a massive opportunity in terms of the Windows ecosystem and building great apps for both platforms. The platforms are converging. I hope that came across today. We have a common .NET engine. We've brought over some common Windows Runtime API. We also have a native app development stack that's very portable across both platforms, and that all sits on top of a shared core. So this convergence is really happening, and it's started significantly in this release. So that's it. The time is right. We'd love you to start building apps for both platforms, and I personally can't wait to see some of your fantastic creations out there in the store. So on behalf of myself and Doug, thanks very much for attending our talk, and we'll take some questions now. Thank you. So I believe I owe an answer to a question that was already answered, if I can just get to that first. You were talking about unit testing. So are you talking about the interface and that having a benefit from the portable class library in terms of being able to mock the interface for unit testing, or do you want to come up and use the... Okay, sorry. Go ahead.
So we saw the code sharing between Windows 8 and Windows Phone 8. Is it possible to do the UI component of Windows Phone 8 in the previous technologies like Silverlight, so that if somebody has written a UI part in Silverlight, but he now wants to use some core logic and wants to share across Windows 8, can the portable class library concept be used in that fashion?
No, unfortunately not. So both platforms, you write your UI using XAML.
Right.
The issue is that although they're very similar in terms of the landscape of controls that are used, they exist in different namespaces. They're actually implemented differently today. We have some documentation on using a user control, for example, to wrap up some common XAML, but your mileage will vary, and really, in terms of sharing, we'd recommend that you look at the layers below your UI to get maximum return on any sharing investment you want to make.
Right.
Hope that answers your question.
Sure. One more small question. So the portable class library that we wrote in .NET, is it also possible to use it in a normal desktop .NET application?
It will depend on what platforms it's targeting. So I believe you can go into your projects and go into the properties for that project and change the targets, and you'll probably see compile errors straight off in terms of whether it's portable for yet another platform. I believe you're able to do that.
And Daniel Plaisted's talk has a lot more detail, goes much deeper on the portable class library.
So Daniel Place's talk will go into a lot more detail. Thank you.
Can you tell how much Media Foundation shared between Windows 8 and Windows Phone 8, specifically regarding the streaming?
Great question. Doug might have the answer. So I actually forgot to do this. I didn't want to show you yet another eye chart, but we have these out there for you to collect, which is showing you all the API available. And there's a tiny legend here, which is actually really important, because it'll show you a little bit more detail in terms of what overlaps with Windows 8 and what's very similar, and then what's got some overlap and no overlap. So that might help you out in terms of...
It actually doesn't mention anything about streaming, but in Windows Foundation here is a new component, or actually different component, that doesn't exist, actually exists, media stream source for Silverlight exists for Windows Phone, previous Windows Phone 7, and nothing exists for the like that exists for Windows 8. Now for Windows 8 you have to use Windows Media Foundation for streaming. And question is, if I build it for Windows 8, can I share it and use for Windows Phone?
Okay, my short answer is I don't know, but I recommend you go to Peter Torr's talk on the native story in terms of the phone, and he'll be able to dig into what level of Direct3D, what level of what's in the Media Foundation libraries in terms of what's supported. I don't know offhand.
When is this, that session?
I believe it is, I think it's on Thursday. It's
Thursday.
repeated on Thursday morning at 8, and I think it's on tomorrow as well. There's 2 of them.
I think it's tomorrow morning.
Tomorrow morning, yeah.
Thank you very much.
Okay, you're welcome. Hello.
Where can I get one of those charts?
Yes.
Where can I get them?
Downstairs, I've seen the big pallet of them.
Got it.
I've one here for someone if you want to grab it.
I'm reading.
I was in the overflow room, so I don't know if anybody asked this question already, but are there any downsides to using a portable class library in terms of performance or anything like that?
There was an overflow room. So, any downsides?
I wouldn't call it downsides. I think there are some limitations.
Yeah.
Things that when we started, we were playing with PixPresenter, there are things we would have liked to have done, but you can't. There were a couple of very similar classes where all we wanted to do was put in a conditional compilation thing and say, we'll just use this namespace on Windows 8 and use this namespace on Windows Phone 8. You can't put that into a portable class library.
Yeah.
But we just put that into our shared, we just
Yeah.
used add as link to share that strategy. So
Yeah.
Okay.
we would have liked to have put more in there, but it's a little tightly controlled. But I don't really think there's a downside as far as performance.
Okay,
Not that I'm aware of, but it's a great question maybe to ask Daniel in his talk.
perfect.
Thank you.
I'm not sure if you answered this already, but portable class library for legacy applications, WPF type stuff, is that possible?
In terms of writing it once and having all those checkboxed so that you target phone, store, WPF? Is that the question?
Yes.
I'd have to look at the wizard to see what set of platforms it currently supports. I can't remember.
One of the nice things about portable class libraries is as you select a particular, if you use the wizard and you select a particular target platform, it will tell you, yeah, I don't know, is that me? It'll tell you, oh, you've selected that, I need to change that.
Yeah.
But for a better answer than we're going to give you, Daniel Playstead's portable
Yeah.
class libraries talk.
How about the Windows runtime components?
In terms of portable library?
Use in legacy applications again.
No, I don't think that's possible. I think this is Windows runtime components in terms of a legacy calling into them. Are you
Yes.
are you porting the legacy to Windows Phone or Windows Store?
Maybe.
So you want to bring existing code forward, put it in a Windows runtime component.
Portions. I mean,
Yeah.
really this is about introp with C++, right? So,
Yeah.
if I want to take some of my code and start using it in native C++, part of my question is if I don't want to be in the App Store, if I want to be a legacy app, can I still use that?
Great question. I'm imagining you'd have different projects if you had something for the App Store, for the Windows Store app or Windows Phone 8 app, and you'd have a legacy project and you just link the same class. You don't need to use Windows runtime components to wrap.
Yeah.
Correct, but I mean, part of this is also, the optimized use of unmanaged C++,
Yeah.
right?
Yeah.
Right.
I mean, for example, one of the things I'm curious about is the underlying technology here is COM, correct?
Yes.
In an legacy type application, would I have to register the DLLs?
Great question. I'm not sure. We keep passing everybody off to the rest of the talks, and I apologize for that. But they are the best. Peter was going to
Peter
show
would know
up
better
here.
than we. But I think what you're going to do is once again, even with the Windows runtime components, the component themselves are not, the libraries aren't portable, but it's the code. So I think what you'll find, and Peter would answer it better than we would, is you'll be able to take that same code and use it in both legacy as well as make it available to the runtime. But you won't be able to make one project that's available to all of them. And I hope I'm answering your question better.
Yeah.
Okay. But Peter Tor is going to give you a better answer than we will.
I just want to stay away from P and Vo, because
Right.
Oh, yeah.
Don't we all?
Don't we all?
So this is probably a dumb question. I just can't find an official denial of this, but Windows Phone does not allow JavaScript HTML apps, or does it? I can't find any documentation on it. I downloaded the SDK.
Great.
It sounded like it was allowed last year. They were talking about, oh yeah, you just use one app, but it isn't around. Do you know?
Yeah.
Yeah, so in terms of use of JavaScript, the official story is that if you're building a web-based, an app that runs inside the web browser controller and you're using standardized JavaScript, that should work. So in terms of similar to Windows 8 and a store app that uses JavaScript, that's not supported.
So I have a Windows 8 store app that is entirely JavaScript, and but I can't seem to find any way to run it in the emulator or anything. Like
Okay.
that is officially supported?
No, not on phone.
Not on phone.
Not
So,
on phone.
so it's not going to be on the phone.
So what you have on the phone is you have the web browser control in IE10. And so if you're writing something like that, that's going to work on both. But a WWA app on Windows, in a Windows Store
WWA
app, is not going to work on Windows Phone. You might be able to, the classic code sharing of cut and paste might work for you, but that's actually not supported.
Okay, there's no word on whether it's going to be supported
So-
ever?
Well, we can't promise.
So there is a talk
Sure.
on the browser and HTML5, and maybe in that talk, that's somewhere you could go and just talk to, because
Okay.
he'd have more insight than us,
Okay.
but that's roughly how it will work on the phone.
All right, thanks.
Thank you.
You talked about the language interop. Is there a F# integration
No.
on the
For a
store
runtime
or in the
component?
phone?
Well, let's see. Runtime component, you can put VB, you can put C#, you can put C++.
No.
I honestly can't tell you if F#'s available.
Okay.
It sure would be cool, though.
Yeah.
So, and I'm not sure who to ask. I think that,
That might be one to chase. I'm not sure myself.
Okay. Thank
yeah.
you.
Good question. Thank you.
Right. So, so the store apps have a subset of the Win32 API available, and I guess Windows Phone also has a subset. Is this the same subset, or are they different subsets?
Great question. So my advice is in the documentation, we've listed out all the API that we've brought over in terms of Win32,
No.
Windows Runtime, and so on. I actually have never put them side by side to see if it's the same subset. So not sure who would I be able to answer the yes or no on that.
It's not on purpose, so probably not. It sounds like the answer is.
What we've done in terms of native is we've brought in a native and the Windows Runtime API to really make our platform sing from a games and app perspective. So I'm not sure where we stopped in terms of what we brought over. I do know I think it's WinSock, and you can see a lot of the code in the documentation. You'll see a list of all the APIs, but I don't know the exact overlap. I apologize.
but it's going to be documented in the
But
docs.
actually, if they say WinSock, I think they said WinSock was not in Windows Store, right?
I think you meant sockets.
No, WinSock.
Is it WinSock?
In
In the
Win32.
Win32.
Yeah,
Yeah.
Win32.
Yeah, I guess, okay.
There's some support there. I have another mic here I didn't even see. Sorry for keeping you
Perfect.
waiting.
So I have a comment on the limitations that you might be stumbling upon when using portable class libraries.
Yeah.
One thing that you should be aware of is like you have to expose all the public properties from the view models, like basics, system types or core types.
Yeah.
And one thing that you usually use in the views is like visibility to actually turn off and on different elements
Yeah.
in lists and views. And you need to be careful there, because if you have to expose booleans from the view models in portable class library, and then you need to use converters in the different
Right.
UI projects,
Yep.
which might hurt performance.
Yeah, in an earlier version of Pix Presenter, we had used something like that, and we found it to be kind of a clunky with sharing in mind.
Yeah.
It didn't work really well for what we were trying to do, so we yanked it and went a different direction.
You could subclass like the view models in your different, but that's just kind of
Right.
advanced.
Yeah, and the same kind of limitations or restrictions exist for other sharing techniques, like the Windows Runtime component. You have a specific set of types that need to be exposed and so on, and the classes are sealed, and there's various other things you can read about, but basically it's the same kind of...
Yeah, just boolean and visibility is very common pattern.
But
Very
our
common.
solution to that one is actually, and you should see a lot of guidance, is to use the Visual State Manager for that type of UI management as opposed to the Booleans. You'll see both in some of the docs, but like if you look at the templates of some of those things like the split and grid, they're really heavy with Visual State Manager, and we found that was, when we were writing this stuff, it got us out of that, and it was fairly convenient way to handle visibility.
Perfect. Thank you.
So as you mentioned earlier, the storage and persistence API is like platform specific, right?
Well,
the storage and persistence API.
So the API used to access the photo library is not available on Windows Phone, but the storage, Windows Runtime Storage API, some of that has been brought over to Windows Phone, just not the piece we were looking at, which is the picture libraries. But you can use them for, I think, local data storage and so on.
Sorry. So basically, we use like a local database, and I didn't really find any databases I could use on Windows 8. So like any SQLite kind of database, right?
Oh,
But now there is a SQLite support on both. So my question really was, if we were to use SQLite in a PCL, would that work, not work?
So I believe the best approach for SQLite will be to actually use, you're going to write to its native APIs probably. So you'll have a native wrapper, I think, which you'll expose in a Windows runtime component. I've heard that talked about before. So then you have access, you're using the native API, wrapping it inside a component and exposing that to your app and coding against that using C# VB or whatever. But I think it's your choice, I think.
Okay. And there's an LOB talk. Kushal Shah is doing a talk on LOB apps, and I think it's specifically just for Windows 8, but I believe he's done some more. I've been working with Kushal, and I believe he's done some stuff with SQLite, so he might be able to give you a better answer than we did, but he may not be familiar with the phone side of things.
Right.
But I think, like Andrew said, you should be able to, I think the story's better than when you looked at it before.
Okay, thanks.
You're welcome.
Hey. Actually, I was very glad to hear you today, because we have come to the absolutely same decisions, because we do components which are for Windows Phone, Silverlight, and Windows 8, and we do absolutely the same.
Great.
The question is, when you have a custom control, which has a XAML template, in many cases, the only difference between XAMLs for different platforms, namely for Windows Phone and Windows 8, is namespace declaration.
So
do you have any hack to not to just copy the entire file and?
That is a big limitation, and you can't conditionally compile XAML. And I've seen other people use quote-unquote hacks to do that. We're not recommending anything. I've seen people talk about loading up XAML at runtime conditionally from a resource and injecting it into an empty page. That's not something I'm recommending, because in terms of time spent doing that versus better experiences or code sharing in the app logic, I don't. For a lot of the apps, I think we'll see out there, I don't think that's worthwhile. But yeah, it is a limitation today. It's nearly a tease, because the controls look the same. Sometimes you just have those import namespaces that are different. We have in our documentation a user control we share, but we had to bring it all the way back down to just a basic, no custom imports at all, no use of anything that would cause conditional compilation. So unfortunately, I'm sure there's other hacks out there, but I've nothing really that I'd recommend officially.
Right now we are considering code generation for that, because the body of the XAML is the same, just code generator.
That would be a way to do it. We weren't really trying to push that story in here. There were better stories for us to talk about today. That one is, but we recognize that. It is limited. It's a limited story.
I've seen people do some things with build definition, and at build time also doing some form of, injection of namespaces. But worth researching. If unfortunately I can't.
Thank you. And one minor question: do you have any convention on namespaces for platform-specific libraries? For example, you have blah blah dot WP8. How do you name that assembly, and what namespace is the default namespace for that assembly?
Yeah, so we don't have any general guidance. We were trying to just put together the namespaces that made sense. So we kind of named, we didn't look at them actually in detail, but
we're trying to fit it all on the screen.
Yeah, but the namespaces we picked, I think, were basically the name of the projects we showed you as well. So pixpresenter.portable, pixpresenter.win8, and so on.
I would just go with the guidance that's already published. I don't think
there's
it's really
nothing new
changed.
there.
We may not have followed it very well, though.
I just have questions on the view models. We're doing something similar to what you guys are, sharing our code across 2 projects, and we're just working on the view models and having troubles with the resources. Is there any plan to have the ResX and the ResWs?
So that's another thing we actually
Your view
played
models
with.
have localized information, right?
Yeah, so part of the PixPresenter app, actually I should have shown it there, was a portable strings class, which is actually a ResX we put inside the portable library. We wrote all the strings for both apps into that one portable library, and we were planning that to be, that's our story in terms of localizing the app. Now the difference is that I think we've diverged slightly in platforms because Windows is into ResW, and we still use ResX, and I'm not really sure, I'm not sure if we wanted to give that guidance here today that, but when I did show this to a colleague of ours who's in the portable class library world, he seemed to think it was a reasonable approach to think about localization and portability.
We just had, time invested in parsing a ResW file to send it to localization and bring it back and regenerate
ResW or ResX?
Well, we went ResW because of the Windows 8. So
I haven't tried it. I did the ResX one, and
so that's in the code that you're posting.
Yes.
Yeah, the portable class library has a ResX file in it.
Yeah.
Okay. Thanks.
Yeah. Thanks very much, folks.